Matt, how's it going?
Oh God, it's been a big one, mate. It's going well. Look, we're going through a few topics obviously before this, and so much has happened since we last talked.
Tons.
KiCad 9 release, which is huge because KiCad's accelerating, which is one of the really cool things about it as a project.
Yes, absolutely. And this was alluded to like 2 months ago, but the guy from JITX, Duncan, was saying he doesn't think that, these other big players are really going to dominate the space for much longer. KiCad is just going to eat everything, and it seems to be doing that.
I think it is slowly. It's kind of a case of if you're just playing catch up, you're trying to get back. You can look at all the examples in the software world of this. Maybe Terraform and sorry, what's the open source Terraform? Please remind me.
It
was tip of my tongue. Easy as Docker and Podman, right? That's right in front of you, right?
That's right.
Where Docker it's actually already open source, or Docker's core, and then they made Docker Desktop, which is a good product and I think well worth paying for. But then all of a sudden, some people just don't like that, and so Podman comes along, and hey presto, there's a competing product on an open standard.
That's right.
And Podman these days, for at least a heck of a lot of applications, is just as good as Docker.
Yeah, absolutely. Absolutely. I mean, Docker is really surviving. Docker is actually, I always give it as a case where you establish your brand and then you get to win forever. Maybe not win the entire space. I think the founder of Docker kind of had to walk away with not a lot.
Yeah.
So you might not win the entire space, especially, and that's a big deal if you raise VC capital. You don't win the whole space. Like your investors have preferred shares, so you might literally walk away with nothing. But they still dominate. Like Docker Hub, that's the expectation for where images go. Even though they're really not the best image registry for that kind of stuff. I don't think so.
Hot takes. Okay, what would you take?
GHCR.
Okay.
So that's the GitHub.
GitHub container
one.
repo.
And honestly, I would probably just use that. Everything open source is on GitHub. You might as well if you're releasing open containers.
Plus, as soon as it's open source, they give you free storage. And so it's kind of hard to do much else with it necessarily.
Yeah.
But
all the cloud providers have image registries that are going to tap into your existing auth system, and just be kind of better.
Yep.
Yeah.
That makes sense. So to take the analogy back to KiCad, though. So KiCad 9, it has a bunch of new, let's say EE-oriented features, which are probably not the huge ones we're going to talk about today because we're selfish, and like the technical details in the back end, and therefore what kind of power it can unlock is at least the interesting part for me.
Yeah, absolutely. What's your favorite feature out of the KiCad 9 release?
There are two, and it's either the embedded files. Being able to create a component and it's a single file, it makes it so much more transportable.
Huge. That's always been the thing that feels like it's been holding KiCad back is
library
the fact
management.
Library management. We've come so far in the world of software with packages and registries, but KiCad was not quite there, and this is a good first step. So embedded files. What does it do? What does it mean to have embedded files?
So embedded files are base 64 encoded. Just for listening, base 64 encoded means that you basically take binary data, and instead of using just purely ones and zeros, which means that you can have like all sorts of control codes and stuff, and you can't just put it in a text file, you re-encode that as 64 just characters that represent the numbers 1 through 64. So you lose a bit of compression because you're using, typically I think it's a 128-bit character to represent only 64 things.
Right.
And so you're losing, 1 out of 6 bits, something like that, 7 bits. So you a little bit of a loss, something on the 15% loss, but then you end up with just like A, B, C through 0, 1, 2, and I think there's a plus and a slash in there. And so you can just put that as a string in JSON and therefore serialize literally any data. Absolutely anything. It's just a byte file. Hell, it could be an exe. I don't know if like KiCad would let you do that. That probably wouldn't be wise to do so, but you could embed absolutely anything in a KiCad footprint.
So let's say you have a PCB and you want to put an image on it, or I guess you can embed. What kind of things can you embed with us?
So the most exciting one, I think, is a step file, because you can embed the 3D model for a component within a single. Well, you can embed everything to do with a component in a single file.
3D rendering is just crazy now. I see the PCBs or the these sort of board renderings out of KiCad, and they look amazing. I don't even know what's going on there. Did they like write that technology? Does it go into Blender or something? Like,
so you can actually connect it to Blender.
Okay, so that must be what people are doing to get this like crazy ray casting. But does it look good inside of KiCad?
I haven't made it so, but I might be able to.
Yeah, you can tweak it around a little bit.
Yeah. I mean, I don't play with it because I don't, like, the 3D rendering's cool, but I don't care personally too much about it.
Right. I think one of the things I've been kind of waiting for, and I'm not a huge KiCad user, but they have this new like component classes sort of thing, which my understanding of it is you can create a component with many subcomponents, footprints, schematic symbols kind of built in, and then you can like move that around. So if you basically it's like a reusable subcircuit. It's something we talk about all the time, but KiCad finally has some way to do this. I guess it didn't have it before.
You were able to do some kind of like sheet reuse type stuff, but it sounds like this component class is, well, it sounds like they've thought about it a lot more, which is really cool.
Yeah.
Do you know if that propagates through to the layout as well?
That's a great question. Let's see if they mention it in the release notes. So let's see. I bet if we stay totally silent, Naz can cut out the silent portions.
Yeah. Thanks, Naz.
Thank you, Naz.
It's enormous. Yeah.
Okay, component classes. James Jackson has added support for a component class feature that allows grouping of various symbols and footprints into classes that can have specific design rules applied. They're set on the symbol in the schematic editor and apply to footprints associated with those symbols. So I think it's a big footprint.
Actually, so I understand that actually very differently, because when I initially read the release, as far as I can tell, what a component class is, you say, this is an op amp, and all of my op amps in my circuit have these DRCs applied, for example.
Oh, I think you're right. So they still, but why did they say it allows grouping of various symbols?
I'm not sure. I don't know. I couldn't say so.
All right, in the comments, get mad at us. Tell us, if we should be excited about component classes.
Well, we don't use schematics, so it's kind of a.
We generate KiCad stuff essentially, like we don't. Yeah, we use the.
We kind of skip the schematic half of things.
Yeah, exactly. We skip the schematic half.
But on that topic, one thing I'm really excited about is the new API. Have you seen this?
Yeah, the IPC API.
Yes.
So what can people do with the KiCad API? What's it there for?
Well, it's okay. So the current plugin or the current API is mainly for plugins. You whatever, you add some little sub feature, it adds a button, you hit a button, and it, I don't know, rearranges some traces for you, or like smooths them out, or does something with your design. The new API, because it runs over IPC, it's an inter-process communication. You can have, in our case, for example, a compiler manipulate a KiCad layout live next to you with both of them open at once, which is obviously super, super cool.
Amazing.
And you could do all sorts of other stuff as well, like the embedded plugin system for KiCad today. It requires Python 3.9, I believe. And so it's like really old Python. It's a pain in the ass to debug. It's a pain in the ass to work with. When it's a separate process, it comes with its own issues in some ways, because any IPC has, you're now working with an API and you might not get good errors. But heck, you can do anything you would normally do in Python.
Yeah, you can use any program. You don't need. You don't even need Python.
You don't even need Python if you don't want to.
And you could also theoretically pipe that over HTTP. I guess
if you
there's
would like
a lot
to.
of possibilities.
Yeah, if you'd like to. So you can do all that type of stuff. You can scale compute externally. You could spool up a GPU if you need the IPC. If you wanted to, you could do layout via it, or auto layout via it. You can also access resources that KiCad might not have ready access to. In the case of both atopile and tscircuit, that means being able to run its own compiler and examining the source to work out if there's some DRC necessary, or the compiler itself can just connect up to KiCad and do the direct layout manipulation instead of having to serialize or pass all of the KiCad files, understand what all those fields mean, support multiple versions, anything like that. And it only needs to know how to do one thing, and that is hit a common API that should be stable, at least theoretically. It's currently in beta, ongoing, which is huge. Not having to support some litany of old file standards is enormous. It's incredible.
Yeah, and it's also just kind of hacky. I do think whoever built the Python kind of binding, somebody made a really good KiCad Python library. Sorry, there's probably 10 of you who have done it, but anyway,
they'll be going, yeah, it was me.
If you edit the files, I think it will show up live in KiCad. Is that right?
No,
Or
it won't show up live. You need to reload.
Oh, that's okay. But with the IPC API,
it'll show up live.
Oh, that's cool.
Which is cool.
Yeah,
which is enormous.
Cool. You could even have like a web GUI in front of KiCad in the theory that like communicates over this. So this is huge. This kind of gives this is kind of like now a usable kernel for people who want to use electronics. And the programs you make also won't need to be bound by GPL because API boundaries don't cover licenses don't go across API boundaries. Asterisks usually, right?
Asterisks usually, typically. No, so that's huge. Actually, the third one I totally forgot about is there's now a CLI command to upgrade old footprint libraries, which is, again, moving towards this place of automation in KiCad, which just means you need to support one thing well and you're good as gold, which is incredible. It's an absolute, it's a huge win for KiCad. And all of this just means that you end up with a richer ecosystem around it, which is really what like an IPC API means.
Right.
And with a richer ecosystem, then you can do more stuff with
absolutely.
more people.
Do you know who else is asking for this or who wanted the IPC API? Like we're obviously interested, but like were there people pushing for this? How did this get done?
Yeah, there's a lot of, I don't know very specifically how it manifested this time around, but actually, I was working with, oh my God, I can't remember his name. It was about 2 years ago, very briefly, a guy in Canada who'd started building one of these basically that interacted with the existing plugin system to standardize that API. There's been talk of it for years because the existing KiCad API for Python was generated using Swig. It was auto-generated based off...
Oh, you're kidding.
No. It was auto-generated off C++. And so it was completely unstable. It made it really hard to write and debug plugins, which meant it just didn't happen as much. So anyone who wanted to automate anything in KiCad has wanted this for a long time.
You know, manufacturers will probably integrate a little bit more handily now, especially if there's like an open source, like, you know, because I think... The plugins that come to mind for KiCad are usually around like putting together fabrication files, loading in DRCs for a manufacturer, maybe seeing if they have part availability. Yeah. So that's probably going to be a big space, I would imagine.
That'd be huge. Yeah. I know that actually also as part of KiCad 9, another one, they have a sort of templated artifact generation. And so you can set up like, I want to send this to JLC, for example, and have one file that dictates how to do that and generate all the correct artifacts. Yeah. Which is awesome because you otherwise have to go in and reconfigure it every time you switch. Yeah. Super annoying. So that's all huge.
It's also JLC's interface, even though it's like the easiest in the industry, maybe PCBWay is kind of close. I don't know. Is there somebody after that? I want to be fair, but
Diodes is the best now.
Oh, Diode Dev. They have they have a command line ordering interface. Is that right?
They have command line ordering, and that's super smooth. It just takes you to a checkout page, and you're like, yeah, I'd love one.
So you put in your PCB, and it goes right to a checkout page. Is that right?
Pretty much, yeah.
That's pretty cool.
It's pretty awesome.
Wow, that is that is sweet. I didn't know they had that. Well, I saw they had a CLI ordering. Where does it? What's like the back end? Do you know? Like, what does it come from JLC in the end?
They have a few of them, so you can select criteria like I want it to be manufactured in the US, for example.
Oh, nice.
And they'll make sure that happens.
Wow, that's pretty cool.
Yeah,
that's pretty cool.
It's pretty awesome stuff.
All right, shout out to Diode. Good job, guys.
Shout out.
Yeah, I guess what else is interesting here? I don't know. That's
anything else in KiCad?
Yeah, interesting in KiCad. I had multiple track drag, but I think they already had that. So.
Dude, no, that's so beautiful. The multiple
okay,
track
that's a big deal. All right, let me find it.
I'm not actually sure materially how helpful it is. But God, is it gorgeous. Like you click 6 traces all at once in parallel and then drag them and they all come together as a bus. Like for practically, there's some technicalities to it because I'm not sure how well it honors some DRCs, for example, but oh my God, so nice.
Oh, it's a video. Okay, let's see.
Oh, is this the multiple? Oh, yeah, there you go.
There we go.
Now we're talking. I wonder if they've got a nudge now as well. I'm not actually sure.
I feel like I gotta hop into KiCad because it like kind of auto routes as you drag, right? Like it does like
to some auto routing. Yeah, exactly.
So nudge is a little different.
Yeah, there
is that nudge right there? So
nudge is as you're dragging another track around. If you're stuck between something and you push against it, it'll nudge the tracks adjacent.
Oh, very nice.
So this isn't quite it. You still have to let go of wherever you're currently doing, grab the thing you want to move it, but you can move a bunch of stuff at once, which is pretty cool.
Yeah, that's cool. Yeah, I wonder if anybody will build like an auto router that basically works using all of these like little sub algorithms KiCad has, because those are kind of non-trivial. Like, I mean, this program's been around for decades and they still haven't built it, so it's not easy.
No, it's far from easy.
Yeah.
I mean, you've been working on auto routers so heavily recently.
Oh yeah.
How's the progress coming?
It's going okay. I think we were talking about this a bit before, and I think when you're building an auto router, you really have to choose between like how successful completion will be, how fast it's going to go, and how good it's going to look. And I have taken down the bar on how good it's going to look so low, because my theory is we're trying to do fully AI generated circuits.
Yep.
We just, you type in a keyboard and you get a keyboard.
Okay.
That's the theory.
Which layout?
Which one now?
Which layout?
Yeah, so you might have to give some details. Default 60. How many? Do you know what default 60% is? Have you ever heard of this?
No.
There's all these weird terms in the keyboard community. It's a really strange community with so many quirks and stuff like that, and weird brands. It's like an ecosystem you participate in. It's like gamers have their weird words. Keyboard community has their weird words. But anyway, so that's kind of the dream. And my theory is nobody will look at the traces, and traces also don't matter much for a keyboard. So I'm focusing on speed and completion, and it's quite ugly. But it's really fun. There's probably like one of my biggest discoveries about auto routers is it's not like one algorithm. It's 12 algorithms with a lot of opinionated choices on how to connect those algorithms together. And so just as an example of one I ran into the other day, you're routing a board and you have a ground net, you have a power net, whatever. There's maybe 20 points in that net. Are you going to use a minimum spanning tree, so kind of like the shortest distances to connect all those points together? Or do you want some redundancy in those connections? Like obviously with a ground plane or a power plane, you have, or a POR, you have a lot of redundant connections. So you kind of make those choices, and they affect way downstream when you start to do high density detailed routing. Yeah, because if you use something like a minimum spanning tree, you're guaranteeing high completion because there's not too many traces. When you go to order the board, there might also not be enough power. But you're doing better to guarantee completion. And if you do lots of traces, your detailed routing phase is going to have a really hard time. So it was a very multi-phase process. Each phase is probably a pretty hard algorithm. And every once in a while, nobody can figure out what to do. They're like, so right now we have this kind of high level routing, and we're trying to figure out what layer a trace should start on. Should it start here or there? And you just kind of throw shit at the wall. You just start trying random possibilities. And then whenever it's an improvement, you change it because the unwrapping algorithm is so hard. People just use a stochastic approach.
Yeah, that makes sense. Now, the ultimate stochastic approach, AI, how does that play into auto routing these days? Yeah,
it's a great question. I've always thought somebody should take this is why my theory is auto routing will be solved, and all I can do right now is really just enable people to solve it. I'm not going to be able to take it down by myself, but it's really a vision problem in a lot of ways. Like even PCB designers refer to their boards as artwork. It's called like PCB artwork. So it really is like a vision generation problem. And what we know is from all the other image generation is the things you think that only humans can do. Sometimes that's not true. AI was really good at generating art. And I think this will be true for PCB design as well. As long as you check and invalidate it, you can generate images all day and say like parts are right, you can regenerate other parts. So I do think it'll be solved. I don't think that I think it'll be solved. I think we just need a really good data set, and somebody will figure it out.
Yeah, interesting. So there's interesting stuff going on there, because there's a huge composite world, as you described, between the pure algorithmic, you run in a circle until you end up with something. And then you end up a little bit back from there to stochastic, where you just try some of those algorithms and see which work. And then all the way at the other end is pure diffusion model. And you're like, pretend it's an image, go bananas. Just give me something that you think looks like a PCB. Which we know is probably a little too guess and checky, hey? You're right.
So, I think it could work.
Pure diffusion?
I think something like pure diffusion could work. You do have to be really good about the representation you put in there. Like, But I do think something like that will work.
Interesting.
Yeah.
Okay.
Yeah.
I'm pretty skeptical about pure diffusion, but one of the things that you just articulated, I think is to bang on, where the way humans do this is they have some high level heuristic. They say microcontroller connects to everything, put in middle, right? Like you make those types of high level decisions of something that like looks about right.
Yeah.
And then you do some detailed routing deterministically.
Right.
And I think that mix is exactly where we're going to see AI enter this.
Yeah.
Because if you can do those things that are super heuristic oriented with something that's really, really good at heuristics, that's all it does. That's all AI is heuristics.
Let me challenge this diffusion
Hit
thing.
it.
I'll go on my rants.
Go for
Even
it.
though I'm not even building a diffusion router because it's kind of like too hard for me.
Okay.
But also, if one person makes a really good standard pipeline traditional auto router that takes effing forever to run but makes really, really good boards, and you generate a large enough data set, like I think what we've discovered with LLMs is it's kind of just compression, right?
Yeah.
And if you have enough, you're just kind of like decompressing, right?
To have enough is super non-trivial in the electronic space, right?
There's a lot.
And the other thing is like language is almost perfect for it. The way that I look at it is I think we've hit AGI. I think we've got general intelligence.
Well, 3.7 came out, Clock 3.7.
Yeah. Oh, yeah. And thank God they
didn't even write it down.
Yeah, God, 3.7. I haven't barely used it. I used it a little bit this morning, but I think we've hit artificial general intelligence. I'm not alone in this. Did you listen to Lex Friedman's most recent podcast?
I haven't. Tell me about it.
The guests. The guest names I really would love to have. So let me just quickly look them up here because they deserve a shout out for their incredible work. But is this Dylan Patel and Nathan Lambert? And those two, they're well within the AI scene, and they had similar opinions. At the end of the day, it's like we've got general intelligence. God, the thing can like be anything between a lawyer and a software engineer. It's incredible. And I think the reason that we're at where we are with LLMs is because language is a human superpower. Basically, we worked out an instruction set that works to recombine and make way more complex abstract concepts that you can sort of packetize and bucket into sections that a brain can reasonably process at a time, right? And then recall and then like sort of reconstruct upon it and grow. And so we've bestowed our superpower upon AI basically in this domain. And I think the thing with the diffusion model, for example, is you see it's like they're good at soft and fuzzy. They make artwork that sort of technically meets a really broad specification, but not the intricate details of this.
Okay, I think I maybe see what you're getting at. Like it's not going to be a diffusion model. It's going to be more like it's going to be a transformer. Is that what you're saying? Or are you not being that specific about it?
I think the difference is, unlike language, and to some degree images, we have an incredibly small data set with PCBs. I don't think we can realistically grow that data set because I don't think we have a good auto router. I think we have some good techniques, but I don't think we're going to get an enormous data set. I don't think we have a good way to express the requirements to a model of what it needs to achieve. And so whether or not the model's good, you haven't given it the requirements. How's it supposed to do anything useful?
No, that's true where like we need to work on, I mean, this is what we both do, like specifying that design intent, like making sure that it's clear what the end user wants so that you know how much current needs to go through a line and how things should be placed. Like it's great if you can route a board, but if the USB port isn't in the right place, it's irrelevant.
Right. I think maybe, and to that note, I think that maybe one of the things we'll see is LLMs guiding deterministic algorithms before we see diffusion models actually being useful in auto routing.
Yeah, it reminds me of this concept. There was an article on Hacker News about a guy who was talking about automating anything. And how he did it is he made a to-do list with each item. And then he would manually check off that to-do list each time he had to do the thing. And then he would just look at the easiest step to automate and just take that out. So maybe what we do is these 12-step auto routers, maybe we just inject a little bit of automation in the relevant place. And you'll probably emerge on something like a human AI interaction. But I'm still skeptical of it. I honestly, if you have the design intent, I want a keyboard, it's like it doesn't take an expert to break down all the requirements of that and get something routed. But you know, for sophisticated boards, you probably will have humans, right? I mean,
well, even without the human, I do think we're going to have auto routers. Don't get me wrong; it's how we actually get there. That well, it's worth needling at, mainly because we're doing it as well. But it's worth needling at.
So, what else is going on in the world?
The Microsoft Majorana quantum computing chip. Now, big news at the moment, or like fairly big news. It's sort of one of those things that's like clearly been a big press release in the sense that they're like obviously want the world to know about this.
Absolutely.
It's not truly going, viral in the sense of it's just running away on its own. But God, is it really cool big tech news,
Yeah. So what are the specs on this? Why is this a big deal?
Today, quantum computers are extremely unstable and hard to operate. They need to be just insanely cold. They need to be insanely insulated from the outside world so you don't actually affect the state of the computer. This is the analog you could think of is a bit flip in memory, which practically just never meaningfully happens on our digital computers, but is the absolute bane of quantum computers. And they've done a couple of things. One is by making what they've called this topological qubit. It separates the state across an area on the board instead of a single particle. And so it's much, much, much less sensitive to noise. If a photon hits one end of this thing, it's not the end of the world, right? It takes a larger amount of energy to kick a qubit out of sync, basically, which is awesome.
That's a huge deal because the whole problem with quantum computers, my understanding is they was always flipping, so you had to run computations more because you can't really trust anything out of it.
You got to do a lot of things with it. The second thing about it is they've made it tiny, right? So they've made these qubits, these topological qubits, like I believe nanoscale, like it's really properly small.
Wow.
Which is awesome because it means that you can fit millions of them or billions of them potentially on what we would consider a normal sized die or a chip, compared to today where you might have 30 of them. It's really
right.
1950s level kind of analog to transistors. And this is taking it, really this is actually just an enormous leap a couple of years in the future. The reason I think of it with auto routers though is because why do we actually care about quantum computers, right?
Right.
Like, have you actually heard of what you would use it for in any way?
I don't know what the first application is. A lot of people say hashing, like to get at that Bitcoin fortune. But other than that, I don't really know what comes to mind. Auto routing would be really great because it is basically looking at, the whole problem with auto routing is the space of possibilities is massive. But if you can run a cost function on the entire space of possibilities, an auto router is not hard. It's just there's too many possibilities to do that.
Yep. And I think, the thing is, my understanding of it, and I'm by no means an expert, but what you could do with a quantum computer is explore let's say a binary space of like, should this be on the left or right of this thing?
Right.
In an enormous way. If you've got, a million qubits, you could store a million left-right elements, for example.
Right.
And you can untangle a circuit just instantaneously in an optimal way.
Yeah.
And that untangling process, as you were describing before, deciding what to do for each step here.
Yeah.
Oh my God.
Yeah. If you could just write a pretty simple cost function, like I want to be this far away from vias and traces need this separation, and then you just give it, almost all of the complexity in auto routers is optimization, how to do it fast. It's like, if you could explore everything, it'd be done. So, that is pretty exciting if we're able to apply it to that. I guess that is a pretty relevant application. I think he even said in an interview, Satya, CEO of Microsoft, I think he said that the first application they would use this board for, this quantum computer for, was building more quantum computers or optimizing their quantum computer. And that definitely resonates with this auto routing thing because chips do auto routing for chip design. So maybe that is literally what they're planning on doing.
Maybe. Wow, that would be pretty incredible. I think the material science aspect of the search there is incredible too. It's
what is this thing made of? Like, what's going on?
Look, the details of this are pretty sparse, and you can imagine. And this is actually one of the other insane things: is Microsoft has been working on this for like 20 years, a long time.
I don't usually associate them with quantum computers either.
No.
This is kind of the first time it's surfaced to the top.
Yeah.
But by default, I trust them more than IBM, who's been talking about this for some time, I think.
Yeah. IBM's been outwardly going for it for a long time. But Microsoft, I certainly would have thought of them myself either. But it's really incredible because you have another example of a private company overtaking a whole bunch of publicly funded, multi-decade career physicists in the discovery and manufacture of like serious deep research.
Absolutely.
We've historically associated this type of deep research with universities and publicly funded institutions, the military, that type of thing. And increasingly, both with AI to some large degree, and now with this materials and quantum computing leap, it's all associated with private industry. It's really interesting.
I wonder if we've had like public research that's needed like this kind of budget just to make any progress. Like this has already happened in pharma, right? Like pharma is mostly private, I think. I don't think you have like universities working on pharma research.
Yeah, I mean, not quite. We do definitely publicly fund a whole bunch of pharma research. An enormous amount, in fact. But I wonder how much of that money is circling around. I've got no idea.
Is there a drug that comes out of a university? This is not a domain I know a lot about.
Yes. So there are drugs and techniques that come out of universities.
All right.
Like fairly regularly.
So this is kind of novel then. So like Microsoft, OpenAI, these kind of like is OpenAI for profit? I don't know. What are we?
For profit. Let's be
for
real.
profit. Okay.
Yeah.
So these for-profit institutions are basically doing like all this very, very important research now. It's just completely left universities.
I guess maybe the interesting thing is like biology, it's been both done in private industry and universities to an extreme depth for a fairly long time, right?
Yeah.
Whereas now we're seeing physics done in private industries at a depth and discovering new physics, like new physics and new maths in the case of AI.
Maybe this has happened in computers for a while because Bell Labs, AT&T,
True.
They were doing transistors. They did a bunch of stuff. So maybe it's just the nature of, I don't know, maybe I don't know. I don't know why with computer stuff, software too, right? Universities don't come up with good software. You know what I'm curious about? The guy who invented object-oriented programming, was that like a university? I'm going to look this up.
Well, so you say, is it a university? Well, I mean, today we have like a Unix, POSIX-oriented operating systems, and BSD, for example, MIT as licenses, BSD as both an OS and you have a Berkeley architecture. I think there is some of the real fundamentals, but maybe it's actually an illustration of where the space is at, and saying that we've matured, I don't know, quantum physics to the point now. Using public resources and using universities is actually a way to look at this, is reaping the benefits of that in private industry now, where finally the public can, or the private can overtake.
A theme with government grants that I see a lot is it's like the government doesn't want to own your intellectual property or whatever.
No, sure.
They're just trying to give you like, they want it to take off. So it kind of like feels weird from an entrepreneurship. You're like, I'm getting all this for nothing. And you're like, yeah, it's because we want it to take off. Like the incentive is just to make it happen.
There's a public benefit to it.
So I guess that's kind of the relationship with universities and companies to some extent. They just want the technology to be adopted.
Yeah.
My college, Rensselaer Polytechnic Institute, had kind of a weird IP policy for a while, where students, like, sometimes they would sign off their IP to the college. They since got rid of this policy, and I don't really think they were executing on it. But that was a little bit weird. So I guess sometimes universities do benefit from like IP created there. They sell it into these companies. So there is that kind of relationship as well.
Yeah. And there's a lot of spin-off labs and things as well. Like a professor will, invent something over decades and then run off basically. And like, sure, the IP or the patent might technically be owned by the university, but as you say, they want it to be something, so they license it or co-license or whatever, but it needs to be taken through to a product or a useful service or something at the end of the day.
Absolutely. Students have too much time on their hands. Actually, anybody in the sort of 17 to 25 year old range is kind of is a little bit dangerous. I think the founders, the people who founded the United States, I think a lot of them were like 22, 23. There's been a lot of talk. Yeah. And there's been a lot of talk about, I'm no history buff, so, but I think they were really young.
Yeah.
But people have been giving Doge a hard time because they recruited a bunch of 20-year-olds.
They recruited a bunch of like 18-year-olds too.
Really?
Yeah.
18 is a little bit young.
Yeah.
The problem with being 18 is you don't have enough professional training, like to be handling sets. I don't want to take the other side of this. I'm a big believer in
really?
like, yeah, I'm a big believer in like getting people who are really motivated and have a lot of energy to go work on important projects, especially in the government, which traditionally pushes that away.
Yeah. I see. I do agree with that. I think the difference is that the government is meant to be an institution that doesn't significantly fail, right? And they are one of the few institutions that is looking at you're not looking for success in the government. You're looking not to break things because that kills people and like stops.
That's true.
Stops the world, like stops fundamental things kind of working.
Let me hit you with a theory here, though.
This sounds so American. Yeah, go for it.
Countries, they're a lot like startups.
Okay.
And for a country to last over 100 years is pretty good. That you're talking about, but it's not that long, right? Like countries don't last that long,
A lot of countries do.
Name one country that's lasted a long time.
Switzerland.
Switzerland. How long has Switzerland been around?
Precisely, you'll have to look it up, but it's been, I believe, about 400 years.
1291. So that's 700. Ooh, that's pretty long.
And the other thing is, like, depending on how you want to look at this, is it like is Boeing? Yeah, is Boeing today? Would you say the companies that came together to form the modern conglomerate that is Boeing, basically? Would you count those companies as having survived in some form or another? Because the difference is with a lot of countries is they morph. Like for example, Germany's a relatively new country, but Germany's a poor example because of the war. But let's see.
Touchy topic, World War II.
Italy. Let's pick Italy. So Italy came together out of a whole bunch of basically small fiefdoms. And
how
lordships.
did Italy come together? I'm no history buff, as I've alluded to here. They were kind of involved in World War II, right?
Oh yeah, they were on the naughty side. They're not the best, but it came together before that, and it wasn't like reformed in a sense after it either. I mean, they've had territory come and go to some minor degree, like Tyrol, for example, in northern Italy still speaks German because it was a chunk of Germany and Austria before that. I believe it was at the end of World War I it got passed across. So there's chunks that move around, little bits and pieces, but ultimately some sub-community that was under some lord within Italy joins a larger federation of states. Is kind of ultimately how that sort of morphs.
Kind of a conglomerate. I see what you're getting at.
It's kind of like a conglomerate of a company. So would you say your startup died because it got bought out and became part of a larger company? I don't think so.
No, it lives on. It lives on in a way. Okay, I see where you're getting at. I guess my kind of point is there's not a rule book for running a country. I think.
You mean a constitution or?
Okay, all right. Nobody knows how to do it for too long of a time, you know? So do you have to have some high risk parts and some low risk parts? I guess that's what I'm kind of suggesting here is like different parts need to be run at different levels of risk. I like the idea of cutting out stuff in the government because it like actually makes up a percentage. It's like it's literally a tax.
It is literally a tax.
So it's like, it like at some point, it felt like it was growing a lot from my perspective.
Yeah, I think that's fair. I think there is definitely something to be done there. I think it just comes down to a stability. You got to ask, how much do I care about this not failing? And that's not a startup mentality, right?
Yeah.
Like you're really just gung-ho.
Well, it can be, right? There are some startups that do have to last and they have instruments that can help them last, right?
Startups that have to last, go for it. What do you mean?
Startups that have to last. Wow, really called me out on that one. Hold on. There was a startup in my adjacent to my Techstars class that was selling reverse life insurance.
Okay.
So they would pay you for your life insurance money slowly. So it's kind of like a reverse mortgage or something like that. But anyway, it's kind of like a long-term...
They pay you as long as you live kind of vibe?
Yeah, they pay you as long as you live.
And then someone gives them your life insurance money when you die.
That's right.
So you're telling me some company has a vested interest in you dying as soon as possible?
Yes. I think a lot of people had ethical qualms with this. You know, I don't really know if that company needs to last either. Is there really there's no way to guarantee that a startup will stick around? Like if you're a startup bank, I guess there's not really. Every startup is going to die.
But I mean, see,
or is somewhat likely.
This is what the government's for at the end of the day is to provide a confident backstop. And if you don't trust the stability of the government, you're kind of cooked, because all of a sudden, say the reason you can have a startup bank or a bank is that's FDIC insured. That's a label that you trust. You're like, okay, if everything goes to hell, at least I'm not going to lose more than, whatever the
Okay. You want to trust the government. All right. But does the government need to have some high risk functions that like it should probably fail in some capacity? Like the point of agencies, I feel like, is almost like they can have different levels of risk, like the people printing the money, whoever does that. I clearly know a lot about government. Whoever's printing money, that's going to be different than, like Doge is like a temporary agency.
Sure, yeah.
That is going to last, I don't know, like 2 years. I don't even know.
I think it has an expiry date. I think it was, a year and a half, 2 years or something before it is intentionally disassembled.
So it can be like higher risk. And I imagine like things like, I don't know, even like something to help a war effort, right, is more of a temporary structure versus a permanent one.
Yep.
So like, I guess my point is a government is more like a conglomerate with an innovation department. You ever heard of these things?
Yeah. No, they're common. Yeah.
What are those called? It's not called an innovation department.
No. It's just like treat it like an internal startup.
That's what they always say.
Yeah, an internal startup is how you have to think of it. But like, I don't know, Waymo is a good example of this within Google, which is already, a super capable tech company.
Is Waymo really within Google, or is Google just own a portion of Waymo?
As far as I understand it, Waymo is within Google. You've got separate stock, but you use all the Google resources. You have access to the full, Google suite of tools.
Do you have the campus with all the food?
I'm not 100% sure on which campus they work, but you get the full suite of Google tools, their version control system all the way through to
the version control system.
Wait, you haven't heard about Google's version? No. I mean, Google's got their own version control system. Google's a company.
They don't use Git.
No, one monorepo for the whole company.
Okay, I've heard about that, but Waymo is inside Google's monorepo?
To my understanding, that's how it works.
What?
Yeah. So they've got part of it.
Is this really a monorepo at this point? It feels crazy. Like, I'm sure you can't download all Google's code because then it would have been leaked by now. So, it sounds like
you need, super duper admin privileges to get through that.
Right. If you can only clone certain directories or whatever, it's really just like GitHub, but they're pretending it's got, it's like GitHub, but with directories for the projects.
Maybe. Every Google engineer I've ever spoke to, and you hear stories about this all the time, of Google engineers leaving going, I'm going to start something because I know, I've learned something on my research and Google doesn't want to pursue it and I want to do it instead.
Right.
So they spin off a startup and then they go, oh, wow. The infrastructure that I was sitting atop while I was doing that work was second to none, and I can't rebuild that. And so they come back. You hear about this all the time.
So you're a big believer in Google's infrastructure.
I don't know if I'd call myself a believer in the sense that I believe it will do anything, but from what I have heard and what
that sounds like not a believer, by the way.
Yeah. No, I don't think it'll do anything in like particular. But I do believe that infrastructure is powerful and it's meaningful. And I do believe that Google has awesome infrastructure.
I bet it'll help you scale, but will it help you move fast? So I know people at Google, Meta, whatever, and the internal AIs they have they don't seem much better than my AI. And they also can't pick what AI they use. And like, I have to switch AI so frequently. Like if I was stuck with just my company's AI, I would not be using the best of the best.